Okay, this is chapter 3-1. This is recording number 2. Okay, let me start by mentioning that we have to be very careful in our language. There can be a lot of confusion, and as an example, the word average. The word average is ambiguous. Do you know what ambiguous means? Ambiguous means that it can have more than one meaning. So the word average is oftentimes used in whatever context, politics or the news or what have you. But what is exactly meant by that is ambiguous because there are three common definitions of, or examples, I should say, three common definitions or examples of average. And there's actually more. We're only going to talk about three, and I'll do like I mentioned to you, I'll do the additional videos later on about some other ones that are very common. But when I say the word average, you should respond by saying, excuse me, which average are you referring to? Are you referring to the mean, the median, or the mode? Because the values will be different. So if I talk about the average salary, for example, it doesn't it doesn't automatically mean the gosh, see, and this is where the language gets crazy because the word mean has another meaning as well. It means to mean something, right? So I apologize for that, but I didn't create the language. All right. So when I talk about something being the average, do I mean the arithmetic mean, otherwise known as the arithmetic average? Do I mean the median? Do I mean the mode? What do I really what do I signify by that? What am I trying to say there? Okay, so you got to be cautious about that language. Okay, why do we care about this? The reason we care about measures of central tendency is because many times we don't care about the actual data points. All we care about is what the average is, otherwise known as, in this case, the arithmetic average, the mean. Okay, as an example, let's suppose I'm the pilot of an airplane, a commercial airplane. And I am told by somebody, whoever tells me, that today I have 200 passengers and I have a crew of 10 people. So there's 200 passengers plus 10, that's 210 people. In order for me to decide how much fuel I need, an important factor is how much weight do I have? How much weight am I carrying? So I need to know what the weight of the passengers would be. I need to know the weight of the freight that I might be carrying, luggage, etc., etc. Okay. Now, obviously, there's other things as well, like the distance you're traveling, what the weather conditions are, the headwinds. All of those are important factors. But let's just focus on the weight of the passengers and the crew. Now, one thing I could do is I could go to everybody, I'm sorry, what did I say? 200 passengers? I could go up to every one of those 200 passengers and say, excuse me, how much do you weigh? Well, that's not very polite and it's a little bit cumbersome. So what really happens is you say, well, I don't care what the actual data point is for each one of those persons. What I care about is is it on average. And on average, I'm going to totally make this up. I have no idea what the answer is. Let's suppose on average, the weight is 170 pounds. So if I have 200 people and on average, the average person weighs 170 pounds, 200 times 170 will give me the total weight. So there's an example of where you use average instead of having the actual data points. You don't care about the actual data points, you just care about the average. Okay, so let's move on. So we're going to talk about the mean. That's also known as the arithmetic average. You've done this before, I'm sure. You add the values of the data points, and then you divide by the total number the total number of values. Okay. All right. So I'll let you read the example there. I'm hoping you've seen this before. Okay. Now we got to get this nomenclature straight. Nomenclature is like language that you use for a particular purpose. Okay. The nomenclature that we're going to use here, or the symbols we're going to use, is if we're talking about a sample, the sample mean, we're going to use X bar. If we're talking about the population mean, we're going to use this symbol here. This is a Greek symbol called mu. Now, as we talked in the last video about if it's a population, it's called a parameter. If it's a sample, it's called a statistic. So that's what he's saying right here. The sample mean is a statistic. The population mean is a parameter. So you got to have those concepts straight. These x's, you have x sub 1, x sub 2, and so forth. The 1, the 2, and so forth, those are called subscripts. S-U-B-S-C-R-I-P-T-S, subscripts. These subscripts are merely used to identify which data points we're talking about. So X sub 1, that's the first guy I am talking about, or the first guy I measure. Let's say I'm talking about weights. So the first person I measure is X sub 1. The second person I measure is X sub 2. The third person I measure is X sub 3, and so forth. So those little subscripts, even though they're numbers, those numbers themselves have no particular meaning. They're just telling us which of the various data points are we dealing with. In theory, you could have just as easily said, well, hey, these people I'm measuring, they have a name, so X sub Bob, X sub Susie, X sub Billy, and so forth. But it's just more cumbersome to do it that way. So what we normally do is we'll do little subscripts. So the little subscripts, X sub 1, X sub 2, X sub 3, and so forth, all the way up to X sub N. And that little n there, the little n, is the total number of data points. So that's what he says right here. N represents the total number of values in the sample. Okay, this symbol right here is called sigma. That's a Greek letter. That's the capital sigma, the capital Greek letter sigma. That tells us add them up. So whenever you see this symbol, what it's telling you to do is add up the various data points. So now do you see how he has it here? Sigma and then this X. It's implied that there's a little subscript to each of these X's, and it's X sub 1 plus X sub 2 plus X sub 3, just like he has it over here. So that's sigma X means add up all of the data points. And then on the bottom here, this N, that's the total number of data points that you have. So that's just a number. If you had 100 people that you were measuring, if you had 1,000 people you're measuring, that's what your N is, okay? So this is for this sample. The exact same concept is true for the population. If you have a population mean, we do the exact same thing. We add up all of these guys. Now, obviously, if you have, these are for discrete values here. If you had, gosh, I don't want to get too far ahead of ourselves. Let me retract that statement. Let's just go back to the text here. So X sub 1, X sub 2, X sub 3, you add them all up. And then now, to help us remember that we're talking about the population instead of talking about the sample, instead of using the little n like we have here, now we're going to use the capital N. So it's the same concept though. Add up all the values, divide by big N. And that's the total number of values in the population. So the way we do this is we use Greek letters like mu, for example, to denote parameters. Denote means to specify or to label. So to denote parameters, we're going to use Greek letters. As an example, mu. For the samples, we're going to use so-called Roman letters. Those are just the normal letters that we use in everyday life. Okay. Now here's an example of where using the word statistic in two different ways can make you nuts. So here's what he says. In statistics, Greek letters are used to denote parameters. Roman letters are used to denote statistics. What in the world's going on here? How come you're using the word statistic here and the word statistic here? Does it mean the same thing? No, it does not. And that's why I said before, it can be very confusing if you don't know about this ahead of time. When he says here, when he says in statistics, what he's saying is in the science of statistics. So in the science of statistics, Greek letters are used to denote parameters. Roman letters are used to denote statistics. In other words, statistics being a characteristic of a sample. Okay, so I'm sorry that we use the same word to mean two different things. It can absolutely drive you crazy, but that's just the way it is. Okay. All right. So whenever you see a mu, you should recognize that I'm talking about the population mean. And if I see a x, this is called x bar here. The x bar is referring to a sample mean. Okay. All right. So we got a rounding rule. Like I say, I don't care about the rounding rules, but you should care. Okay. All right. What it boils down to is a mean is rounded off to one more decimal place. So if the raw data is in whole numbers, the mean is rounded off to the nearest tenth. Okay. Now it's important to recognize that the mean here, the arithmetic average, there is absolutely no requirement whatsoever that the mean be anything. I'm sorry, there's no requirement that the mean be a real value. In other words, I'm sure you've heard this before. You've heard people say the average American family has 2.3 children. Well, obviously, you cannot have 2.3 children. Obviously, you can't have a 0.3 of a child, okay? So you don't have to have a mean that makes any sense. It's a mean, it's an average, okay? So here's another example of that concept. Example 3-1, we're talking about avian flu cases. The number of confirmed flu cases for a nine-year period is blah, blah, blah. Find the mean. Well, this is presumably a sample, I guess, because he's using X bar. So you add them up and divide by the number of guys that are in the set. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's nine data points. Add these guys up, you get 578. So there's 64.2 cases. Well, you can't have, as a human being, right? So you have a certain number of cases. You can have 64 cases, you can have 65 cases, but you can't have 64.2. But this illustrates the point that the value does not need to be the mean does not need to be anything that could possibly be a true value. Okay. All right. So you get the idea, I'm sure. Do the examples, and I'm sure it'll be very clear. And then here it is. The mean in most cases is not an actual data value. It's not even an actual potential data value. Using the example of 0.3 kids, you can't have 0.3 kids. Okay. All right. So the arithmetic average, certainly easy enough to do the calculation. Okay. Now, we learned in a previous chapter how to handle this grouped data business, okay? How to do the tables. Well, the concept here is that we want to actually do this we want to find out what the mean is for group data as well. So how do we do that? So that'll be the subject of the next video. Each of these videos can only be 15 minutes long. So sometimes obviously I have to make several videos on some of these chapters. So that'll be the end of this video.